Chapter 8, Review Exercises, question E77. We're just doing true or false here. The first one, I think we imply you should always look at the data before writing the null and alternative hypotheses. So why is this false? It sounds like a good thing to make sure you're looking at the data. Well, there's certain things in the research design that you need to do before, in fact, really you want to do it before you even collect the data. And one of those is writing the null hypothesis, the alternative hypothesis, choosing your level of significance. All of these things you want to do before you even start working with the data, because those are going to establish kind of your target for knowing whether or not the data will then reject the null hypothesis. All else being equal, using a one-sided test will result in a larger p-value than using a two-sided test. Okay, and that is false. So a p-value is not going to be affected by whether you're using a one-sided or a two-sided. What will be affected is your alpha level, so the level of significance, that alpha character. But the p-value itself is going to come straight from the data, so that's not dependent on your decision. Whereas one-sided, two-sided, those are things that refer to your decision. Those are kind of part of what you do before you collect the data even. The p-value is the probability that the null hypothesis is true. False. That's completely false. In fact, we don't know, there's no value that we know that tells us the probability that the null hypothesis is true or that it's false. We can never really know that probability, which is a very important probability to know, and yet it wouldn't be possible to get at this. Only God would know whether or not the null hypothesis is true. A statistically significant result means that the p-value is small. Yeah, this one is pretty much true. So it means that it's smaller than whatever we decided to set up as our level of significance. So before we even collected the data, before the researcher collected the data, they set up a level of significance, an alpha level, that there was their cutoff level. And if their p-value is below that, then they're going to reject the null hypothesis and they will have a statistically significant result. However, theoretically, I mean, you could create a high level of significance. So just because your p-value is lower than alpha doesn't necessarily mean the p-value is small, because the alpha could be kind of high too. But typically we want a fairly low alpha. So if we do reject, if we do get a statistically significant result, that means that our p-value was small. And certainly it was smaller than alpha in any case.